And hello everyone, welcome back to another Python tutorial. In this tutorial, we'll be taking a look at variables and data types in Python. Now, what exactly is a variable? A variable is pretty much a container in which we can store some values that we create in Python. For example, let's say I want to store my name in Python. I just type out name, make it equal to, and then in quotes say it's as simple as that. Now this name here is called a variable. We can now go and print name. So here where we say name, and if you hover over you can even see Steve. So this name here will pretty much print Steve, as you can see. A variable can pretty much hold any type, so if we go here and say age, that is equal to, well, I'm 22 now, so let's say 22, and if you do age here, we save it, we run it, we get 22. You can have multiple variables, so here I can also still access the name. So if we go like this, there we go. You might be wondering for yourself, but okay, this is cool and all, but what exactly makes this useful? Well, that is where things like this will come in. So imagine you're writing a book or a script or something, and you go, my name is Jack, I'm 22 years old. Tomorrow, my name will still be Jack, but I will be 23 years old. Once I feel like it, I would like to change my name to Tom. Now imagine this story here was 5,000 lines long. And imagine you want to change the name of Jack. So the character's name should now be Billy instead. But take a moment and imagine you accidentally mistyped and you said JSCK instead of JACK. So now if you were to just go and globally replace Jack with Billy, and you say, yeah, go replace all of it, you'll see Billy is here, but this is still wrong. So what a variable does is it can not only prevent these misspells in this scenario, but it can also make it a lot easier to do a one-time change to everything. So here, instead of saying Jack, let's say name. Here as well. Name. And in here where it says the age, let's go age. So now if we run this, we'll see, and let's just make this a tiny bit bigger. My name is Steve. I am 22 years old. Tomorrow my name will still be Steve, but I will be 23 years old. Once I feel like it, I would like to change my name to Tom. Now let's say we wanted to change the main character's name from Steve to Jerry. Now if we were to run this, my name is Jerry. Tomorrow my name will still be Jerry. And in here of course we have Tom. Alright, but now let's say we change the character's age to be 50. But now we have an issue because they're 50 years old, but tomorrow they will be 23 years old. That doesn't make any sense. So instead what we do is we go here, age plus 1, and there we go. So this will add 1 because this is a number. So we can add 1 to this number. So now if we run this, he's 50 years old, but tomorrow he will be 51. No matter what we make this, we can make this massive number, and now if we run it, it will perfectly increment it by 1. And now let's say here, at this point, they say, I, Tom, will be going to the park. So from this point on in the story, their name has changed to Tom. Now we have an issue again. Now we have to go and find all of the Toms. You might think, let's just create a name2 variable. But in fact, it would just be better if we went here, make these both name, and of course we don't need that end part there. But now we have an issue because now there will always be Jerry, so it doesn't make sense. The story no longer makes sense. Now at the point in the story where the name of the character has changed, we could just go name is equal to Tom. So we are now resetting the name to a different variable, to a different value. So name will no longer be Jerry like it is here. It will now become Tom. Now if we run this, you'll notice here it says Tom, but up here it says Jerry. Where you place this is very important, because as discussed in previous tutorials, code always moves from top to bottom. Meaning if I were going to put this here, then everywhere in my code it will say Tom, it will not say Jerry. Because as soon as it hits this, everything following this variable will now use Tom when it's referencing this variable. So we are reassigning it to a new value here, and after this it will use this new value. You can do the same with age. You could go age is equal to age plus 1. So we're taking the value that's already stored in age, and we're adding 1 to it and then assigning it to age again. Alternatively, you could go plus equal age, and this will still work perfectly fine. So if we run this like this, it will still give us, not plus equal age, my bad, plus equal 1. It will still give us the value we expect, because in this case it will take age and it's just a shorter version of age plus 1. But I'll save this for the math tutorial, so we're not going to focus too much on this. So that is variables and their use of it. But now we have to also take into consideration that variables have different types. So this here, this is a string or a text. So anything in these quotes is text, but you can call it a string. This is an int, or a number would be probably more preferable. However, you also have a floating point value, for example, weight 89.6. This is a float, but it's also a number. Both of these are numbers. This int here just doesn't have a floating point value. This is a whole number. While this here is a float, as you can see. And this here is an int. In this case, it just says literal, but just imagine this is an int. You also have yes, no values. For example, is programmer true? Where true is equal to yes, and false is equal to no. So they are a programmer, is programmer. Then of course you have null values. So these are just empty values, so empty value, which is something like none. None is just pretty much you're creating a variable here and it contains nothing. It is empty. So if you're coming from a different language, this would be something like undefined or null or whatever you have in that language. You do have more complex types, but I'm not going to cover them. But you do have things like lists, which is pretty much a collection of items. I'm not going to cover these. They have their own separate tutorial coming up. But you do have more complex options available to you. You can set a specific type of a variable by saying something like string, and then enclosing this like this. Hover over it. Now it will say string instead of literal, because we have specified this should be a string. If I were to put a number in here like 89 and say print name, we get 89. However, this is still considered a string even though we put an integer in here. We can even put something like true in here. If we run this, we'll get true. It's still considered a string because we are pretty much converting the type to a string. It is also possible to assign variables to other variables. For example, older age, and we'll make that equal to age. And now older age will have the same value as age. However, take note that these two are not the same. If I change older age to add 1, older age will be added with 1. And if I were to change age after older age, so I'd say 1. Or let's make this 10 so we can actually see the difference. You'll notice here it increased it with 10. I don't know, I lagged there for a second. And here it did not. Because age and older age is not the same thing in this scenario. If we were to change age before we assigned it to older age here, then, let me just save that, then it would have made a difference. But because it happened afterwards and age is not older age, we are just assigning the value inside of age to also be on older age. And that is why there's a difference in what's happening here. So assigning one variable to another variable does not link them, it just copies the value over and creates a new variable. Now you might have noticed that here I use underscores. Now this is just a recommended practice when creating variable names. For example, you could do camel case, for example, my name, this is camel case. You also have Pascal case like your name. Just whatever you do, don't do your name. This is weird, nobody likes it when you do this. It's recommended in Python to use a snake case, that's with underscores splitting each word apart. But it is also accepted to use camel case. We don't really like this or this, but camel case can also work. However, it's recommended to use snake case. You cannot start variable names off with a number or a special character, so you'll see I go red because it's just not allowed. This not allowed. Special characters, so if I go here, you'll notice, again, whoa, what are you doing? Go away. You'll notice, again, red, not allowed. You can use numbers after a letter, so you need at least one letter before you can put a number in there. It's also okay to go letter underscore number, that's also fine. So it shouldn't start with number and it shouldn't contain any special characters. Also, make your variables descriptive. It's always recommended to, whatever you do, don't just go a is equal to. For tutorial's sake, that's fine, but for actual programming, it's gonna send you down a big rabbit hole if you leave that piece of code and come back to it later. So it's always recommended to just give it a proper name. For example, name, age, weight is programmer empty value, because it explains what it does. That's just some coding practice I would recommend. And that's the basics of variables. If you're still feeling a little unsure about it, don't worry. In future tutorials, we will be taking deeper dives into variables and using them more and more and more until you feel most comfortable with them. But pretty much, you just assign a word to a value, or a value to a word. And then whenever you call that value, that word, then it will return a value for you. Thank you all for watching. I hope you all enjoyed, and I will see you all again in the next Python tutorial.